Hey everybody, my name is Ankit Singh, student of BE Computer Science and Engineering, and today we are going to discuss about quicksort algorithm. So here's the content of the presentation. First we will see a quick view on what is quicksort, and then we will see how this quicksort algorithm works, and then we will see its algorithm, its analysis, advantages and disadvantages. So what is quicksort? Before going to the quicksort, first we should know about what is sorting. Sorting is nothing but arranging the element in ascending or descending order present inside the array. An array is nothing just a data structure which stores the data or numbers. So there are many algorithms which are present in the computer science to arrange the data in ascending or descending order. Among them, quicksort is very famous. So first we are going to see what is quicksort. Quicksort is a famous sorting algorithm and it sorts the given data into ascending or descending as our wish, and it uses the idea of divide and conquer. So divide and conquer is a kind of method which we use in designing the algorithm. So there are many methods like brute force, divide and conquer, decrease and conquer, and greedy method to designing an algorithm. So among them it uses only divide and conquer approach, and it follows a recursive algorithm. Recursive is nothing but when a function calls itself again and again till a base condition where it terminates. It is known as a recursive algorithm. So here's how quicksort actually works. It divides the given array into the two sections using partitioning element called a pivot. So quicksort actually divides the given big array into the smaller parts, two parts, and from where it divides it is known as partitioning part, that is pivot. And the division is performed such that all the elements on to the left side of the pivot are smaller than pivot, and all the elements on right hand side of the pivot are greater than. Like if there are two parts and there is one element in between, so the left side will be smaller than pivot, and the right hand side elements are the element which are greater than pivot elements. And after dividing the subarray into a two part, the pivot is set to the correct position. Like we will take the pivot and put it its proper place. It should be third, fourth, or n number of places where it should be placed. And then the sub-arrays are sorted separately by applying quicksort algorithm recursively. As I told you, quicksort is a recursive algorithm. So first we will divide the subarray, and in that subarray, small subarray, we will again apply that quicksort algorithm. So here we are considering an example to understand quicksort. Consider the following array has to be sorted in ascending order using quicksort algorithm. And here it is array 25, 10, 30, 15, 20 and 28, as we see that all the elements are randomly arranged and there are 6 elements are there. So it's starting from 0, 1, 2, 3, 4, 5, and we will arrange this in the ascending order using quicksort algorithm. So initially we will consider left and loc. Loc is nothing but pivot told before, and as a point of the to the first element of the array, this 25 a of 0 will be considered as this location, and left, and this a0, a1, a2, a3 is nothing but index values of the array. It just gives an address or a symbol that that element is present at this particular location in the array, and right points to the last element of the array. This right variable is pointing to the last element of the array. So we begin this sorting. Here we will first consider this location at 0, left at 0 and right at 5 as like this. I've written here like this we will write. So we will sort from here. And in step 2 we are saying since location points to at left, so the algorithm starts from right. Where the location is pointing now, we just start from opposite. If it is pointing at left, we will take right, and if it's pointing at right, we will take it left. And as we can see that the a of location a of location is 25, and a of right means 28. Here the 28 is greater than 25, a of right is 20 greater, so the algorithm moves to the right hand side. So it is moving to the right hand side. So here we can see that the location point, initially it was pointing at left, and so the algorithm starting from right, but from the right, when we compare, we get to know that the A of location is greater than A of right. So the algorithm swaps the location and right, like the which is at left, we will come at location, and the location will go to the right, and the location will point at right itself. So it will look like something like this. Again, when we'll go to the step 4, we can see the location points to the right, and so the algorithm starts from the left. As I told you, where the location is there, we will start from the opposite. If it is left, we can start it right, we can start left. So we can see the algorithm starting from left, and we can see that the A of location is greater than A of left. So the algorithm moves to the left one position right hand side. So we are moving the left variable to one right hand side, and we are updating here location at 4, left at 1, and right at 4. So again, since the location point at right, we are starting from left, and the A of location is greater than A of left. So again, since it is greater, so we will move the left variable towards right hand side. So we will update the value here again, location at 4, left at 2, A of 2, and right at 4 only, it will not move. So again, the changes occurred here since the A of location is less than A of left. Because of that, the swapping operation has taken place. So 30 was at A of 2, but it shifted to A of 4. The swapping operation has taken place. So that's it. And we will update the value here. Location will become 2, left will be 2, and right. So again, here the same thing will be happen. Since the location points at left, we will start the algorithm from the right. And as we can see that A of location is less than A of right, so the algorithm moves right one position towards left. So we will move this. Initially it was here, this right was here, but we will move it to one left hand side, and we will update the value here, location at 2, left at 2, and right at 3. Here again, when we compare those two values, we will see that the A of 2 will be greater than A of 3, means the A of location will be greater than A of right. So we will again conduct the swapping operation. So 25 will come at 3, and 15 will come to A of 2, and it will look like this. Location is here again, we can see here, and we'll update the value here. Location is 3, left at 2, and right at 3. So we can see here. Now again, we will when we compare, so A of location is greater than A of left, so the left will move to one position right hand side, and here left and right came at the same index. Now further we cannot go forward, as we can see on next slide. Since location left and right points to the same element, the indentation of the termination position, like this, it is a base condition. As I told you, recursion, it calls the function again and again till one base condition where it terminates. So here the base condition is when the left and right comes at the same index. So it indicates the termination position, and the pivot element 25 is placed at its final position. Now 25 is comes at its proper position, A of 3, and as you can notice here, left elements from the 25 are smaller than 25, and right subarray is greater than 25. Again, we will apply the quicksort to this subarray and arrange in ascending order, and we will copy paste here also. So here is the algorithm of the quicksort. We can write the quicksort A of else here, like we have said. Now we will take the array and we divide in subarray part, small part. So here's the sub part is this A of else here. It is comment sort the subarray by quicksort. Input is the subarray of which is the part of a main array which starts from 0 to n minus 1, and the output will be subarray which will be arranged into the ascending order. So if left is smaller than right, as I told you, when it will come to the same position, it will terminate. So it's the termination condition. So the positioning element which we are taking pivot, it is, we will store the partition, which is another algorithm. we will write for algorithm for that also, and we will pass entire array from that partition, and again recursively we are sorting left sub array. We will again apply quick sort, and to the right sub array we will again apply quick sort. So here's the analysis part. To find the location of an element that splits the array into two parts, order of n operation are required. Order of n means we are visiting each and every element. That's why order of n. Because sorting means if you are arranging the elements into the ascending order given 5 numbers, so you have to compare each and every number with each other. That's why order of n. So it is the same, it is written because every element should be compared with the partition element, and after the division each section is examined separately. Like we have to do recursively again we have to apply the uh, algorithm. And if the array is split approximately into the half, which is not usual, like if it is given into four parts, like 8 elements total, so you are dividing into the two parts, so that's it, it is written approximately half. So it is not usual, it will give 9 elements, 11 elements. So then there will be log base 2 and splits, so it is just a formula. And then there will be total number of comparisons required are f of n is equal to n into x, n into log base 2n, and which is written in order of n log base 2n. So it is the final formula which gives the total number of comparisons which we are doing. So here's the advantages of quicksort algorithm. The quicksort is an in-place sort, so it requires no temporary memory. So there is no required of temp variable to sort the given array. We just require left and right, so it is an efficient one. And quick sort is typically faster than other algorithms. As I told you before, it is very famous, and because its inner loop can be efficiently implemented, it's designed in such a way that inside its inner loops, like for if condition and recursive algorithms, it is implemented very easily by the computers. So it's the advantage. Now we will see its disadvantages. So the disadvantages are the worst complexity of the quick sort is order of n square. This is nothing but if you are arranging the element in ascending order, an entire array is given in descending order. So you have to do the comparisons again and again and again. So this is one of the worst case of sorting algorithm, and this complexity is worse than order of n log base n, and worst complexity of algorithm like merge sort and heap sort. Merge sort and heap sort doesn't have these kinds of complexity. It is very simpler to solve. And the one more disadvantage is it is using recursive algorithm, and recursion means the function is applying again and again. So it consumes more and more memory. So thank you guys. We will again meet in the next video, and bye bye.